Coming up on this episode of Control Talk Now.
It basically is a tool for users through simple point and click to be able to create AI algorithms, the behavior of the machine to predict problems. Technicians running around all day, putting out fires, sometimes literally, and that end user could gain from the insights that we provide on the predictive maintenance side.
Welcome to episode 411 of Control Talk Now, where we discuss all things HVAC and smart building controls, including sales and marketing. My name is Eric Stromquist, and this week we're going to take a look at how you can use AI in buildings today and make a real difference. My guest is Jeff Kimmel. Jeff is the CEO and co-founder of a company called Elipsa. Elipsa, as you'll hear, is using AI and machine learning to, among other things, reduce downtime in buildings and industrial plants. And they're using the unique predictive AI models. And the best part is you can get this right now through Niagara Data Services. We have so much to dive into with Jeff, so you're not going to want to miss this. But before we get to Jeff, a quick word from this week's sponsor.
Ladies and gentlemen, the story you are about to hear is true.
Old radio shows are fun, but old ways of doing things aren't. Sevenox is a new way of doing after-hours HVAC scheduling. Sevenox is a cloud-based application that automates tenant after-hours heating and air conditioning requests. Tenants can book requests right from their smartphones and web browsers. No more wasted time wrangling spreadsheets and generating invoices each month. Billing is fully automated, with monthly emails and accurate invoices sent directly to your inbox. And because tenants can manage their own bookings, last-minute cancellations won't result in wasted energy heating and cooling empty spaces. Start doing things the new way. To learn more about Sevenox or to schedule a free demo, visit sevenox.com.
Well done, Brian. Very, very creative. For those of us of a certain age, we grew up watching Dragnet. Brian and Elwin from Ops System Solutions are doing some really cool things and are starting to make an impact in North America. I interviewed them on episode 402, and I'll put a link in the show notes so you can check it out. So if you want to be seen and heard by the global control trends community, you can also be a sponsor of the show. I'll put a link in the show notes. But now it is my pleasure to introduce Jeff Kimmel. All right, I'm really excited about my guest this week. His name is Jeff Kimmel. Jeff is the co-founder and CEO of Elipsa. Jeff, man, thanks for taking some time to talk with us.
Yeah, no, thanks. I'm excited to be here, Eric.
Well, cool. Well, tell our audience a little bit about Elipsa.
Yeah, so
what you guys do.
So Elipsa is at its root automated machine learning platform. So what does that mean? It basically is a tool for users through simple point and click to be able to create AI algorithms that are applicable to industrial use cases and machinery. Yeah.
Okay, well, you said a mouthful there, so let's sort of break that down a little bit. So we're hearing a lot about artificial intelligence, right? That seems to be the big buzzword. Yeah. And I'm taking you've been working with it for a while, right?
Yeah. So my background is in computer science analytics, but actually in the financial service space for a number of years, where that technology and use of technology is prevalent. But as AI started to grow, and what I mean by that is, within pop culture, Hollywood, everyone starts to talk about what AI is. As I started looking at it, I'm like, well, people aren't actually using it. And why is that? And, especially areas that are underserved by, say, data scientists, which are industrial buildings, things like that. So we sought out to create a tool, a platform that was easy to understand and implement AI for applicable use cases, within the spaces that we work.
So is it an interface? Does it allow your, like if I'm an owner and I've got a bunch of machinery or controllers, for that matter, in a space, is it sort of a platform that allows me to interface with those machines in such a way that I can teach it stuff or have it use artificial intelligence?
Yeah, so we have the ability to plug data from, say, a building management system, or really any system where you've collected data, where you can either call HTTP API or send data via MQTT. If you send the data to Elipsa, we automatically can build a series of different AI models. And what I mean by AI models is, let's say, predictive maintenance is one. So, fault detection and diagnostics. But instead of writing all these rules for specific types of equipment and applying it across a variety of different types of equipment, you stream the data to Elipsa. It learns what the behavior of that machine is to then be able to predict problems before they occur.
I got you. So I get maybe I guess a way to ask the question again, just because this is, I think, a key distinction is what is AI and what is it not when it comes to smart buildings.
Yeah, I mean, so that's AI. It's a loaded term, right? And it's a lot of it is because of what people have heard and what they know. So, I mentioned it's pop culture, Hollywood. It started with robots are coming to take over the world. Then Alexa came out, and it's like, okay, I can, it can answer questions, self-driving cars, and now the big one is obviously ChatGPT, which is, has use if you're potentially a tech on site and you want to ask your AI a question, it comes back with an answer. But, with we were at AHR this year, and on one of the panels on making buildings intelligent versus smart, mentioned ChatGPT, and originally I was like, it's clouding the definition again, because really, if you look at what we're doing, the applicability is machine learning. So taking your machine data and learning specific things, like I mentioned, predictive maintenance. So learning the behavior of the machine to predict problems in advance. So then the application there is you can, optimize your schedule of maintenance technicians, et cetera, or learning what the energy consumption of a chiller is or any specific type of machine to be able to then, using a digital twin, create various scenarios of saying like, okay, well, if the weather is going to be this and it's a work day and et cetera, what will my energy consumption be? What will my thermal load be? Something that you're using your machine's data, which you've been collecting for years, but using it to answer a question of what do you need to know in advance? What's valuable to you? Obviously the image recognition could be valuable for security purposes in a building, but if everyone thinks AI is ChatGPT, they immediately think, well, this isn't for me. So the idea is to use machine learning in your machine data to answer the question of what information would be valuable to you if a computer was able to tell me that in advance.
So is machine learning a subset of AI, or is it completely different?
It is, yeah. So you think about like AI, like we mentioned ChatGPT, that's say like natural language processing. That's a subset. You have the computer vision, that's a subset. Deep learning, different things. So machine learning is a subset of AI that just doesn't get talked about as much as the other ones because it's not as cool and sexy. But
yeah, but that's where the fruit is, right?
Exactly.
I mean, if you got a building, it's the machine learning. Okay. So I'm going to give you a use case for ChatGPT, probably the best use case and maybe the only one that's really valid. So for about 3 weeks, I was using ChatGPT pretty regularly, Jeff. And what I was doing was my wife's name is Anna. So it'd say, write a love poem from Eric to Anna in the style of Shelley or Keats, or write a short story about Eric's love for Anna in the style of F. Scott Fitzgerald. Yeah. And it was really good at that. So,
perfect.
Yeah. So for our audience who might not know, and I'm assuming that most of them do, but for them that don't know, you use the term digital twin. Let's define that for them, because I think that's a key piece with all this.
Yeah. So I think at the root, the digital twin is literally a digital representation of, in this case, your building, but it could be any specific type of machine, et cetera. But similar to like smart buildings, right? It's like a digital twin is just a visual representation. So in its root, it just could be, okay, here's a visual of my chiller, or AHU, down to the real-time data, et cetera. Adding an AI to that, though, with a digital twin allows you to then really create scenarios to determine, what does my building look like right now, but what will my building do? And the digital twin is, capable of doing that without having to make changes to your building and to the equipment itself. So it's a digital representation of that.
Yeah. So in other words, you try something and you would do it live with your building. Maybe you blow something up in your building, make a costly mistake with the digital twin. You blow it up digitally. Well, that's okay. You can get those bits and bytes and blinking lights
Yeah.
back pretty inexpensively.
Yeah, exactly.
So cool. So cool. So you guys, primarily then your product, again, I want to get back to Elipsa a little bit because it sounds like it's really cool. It seems like that's the piece that brings everything together. Is that an accurate assessment?
Yeah, I mean, it's really the piece that, you have data from your buildings, but, data needs to turn into information for you to do anything with it. And to do anything with it is one of two things. You could have, so we're creating those insights, we're creating the information, and it's automated through the AI. But then the, predictive maintenance, that could be the insight turns into an alert for a human to go look at it. When we're talking about optimization of energy, it could turn into a data point to actually feed back to your BMS for control purposes. So the, what you do with that data depends on the circumstance, but you're right. We're kind of that middle piece, that is really, like you said, the missing piece to be able to make intelligent buildings, as opposed to just saying like, hey, all of a sudden I can visualize what my building looks like, which you could never do before, so it's like, that's great, but all right, what's next?
Yeah, that makes a lot of sense. So I'm a customer, and well, first of all, describe your sort of typical or ideal customer. I mean, it seems like this could apply to a lot of different people, but vis-a-vis our industry, who are you normally talking to? And
yeah, so there's two different sides to it. It depends on the value you're getting out of it. So if we're talking the predictive maintenance, fault detection, the real end user customer there is on the maintenance side and operation of a building. Being able to, you have a campus of buildings, you have your technicians running around all day, putting out fires, sometimes literally, and that end user could gain from the insights that we provide on the predictive maintenance side. In addition to that, though, on the energy side and really just, understanding building predictions around the buildings itself, it's a lot of portfolios of buildings, so building owners and building managers. So really there, let's say it's someone who's a sustainability, engineer, or someone who's tasked with, better understanding or reducing costs of utilities. Or even, like I said, on the investment side, you could build AI algorithms that say, okay, I want to buy this property. Based on my other properties, what is this one going to look like if I purchase it? Wow. So it's to your point, it's a variety of different things that can be done. And that's the type of conversation that's, better about AI, of talking about what's really applicable within this space, as opposed to the clouded definition that's out there in the real world. But
no, it makes a lot of sense. Well, the predictive maintenance is a big thing. I think it's for the maintenance staffs, because again, if you start thinking about it, what I'm gathering would be okay, based on the information we've gathered, the motor in this air handling unit is probably going to go bad, or has a high probability of going bad in the next 2 weeks. So you might want to have somebody scheduled. Let's make sure we got the replacement part in. Is that kind of how that end of it will work?
Yeah, that's right. So there's a few different ways that you could do predictive maintenance. There's telling it exactly how long to fail and what type of problem it is. But for that, you need thousands of examples of failure to then teach the system, which hopefully people don't have all those examples. So, but you could do that with our system. But the first thing we start with is outlier detection and anomalies, and really like learning what's normal for, say, that motor. And then as it trends away, and not just that individual data point, though, it could be, you could be looking at the speed of a fan as in addition to the outside air temp or supply temp, et cetera, finding patterns in the data that indicate, to your point, that something's going to go wrong.
That makes a lot of sense. And I know some of the controllers, some of the actuators from some of the manufacturers, for instance, are actually building in predictability too, which I suppose you could probably draw those data points out. It says, hey, I've done this many cycles. My average number of cycles is this, which would be really, really useful, because again, I think with maintenance staffs, especially some of these big, facilities, running thin, right? We've got a lot of people retiring. I think that one of the ways we're going to solve the problem is with people that have products like you that can help us with the prediction side of it, because we can predict it. we don't have people running all over. I mean, it's kind of a planned chaos instead of unplanned chaos.
Yeah, it really prioritizes things for the technical staff. And then on tying that into the digital twin side too, you could say, okay, looks like my temperature is trending up. Rather than waiting for it to happen, if I were to create a scenario where the temperature is here, would my machine fail under that circumstance, so that you could start to figure out and get ahead of it as well?
Got you. And then I'm assuming your software keeps track of all that. So once you get those relationships, those connections, if you will, your software, is able to take that in. Does your software do some of the prediction too? In other words, we look at your monitoring. We'll just use the actuators again, and maybe actuators versus temperature, whatever the variables you want.
Yep.
So you're monitoring these things. Does your software actually sort of go in and then begin based on past history to be able to make predictions? So is that part of what comes with all?
Yeah, exactly. So basically, every model that's built, every AI model, and then the key to this too is there's no master model for an actuator, right? We actually build an individual AI model for each piece of equipment or each component of that equipment. Because as you know, let's say it's within a VAV, you could have hundreds of VAVs in a building. They're all going to perform differently from each other. So our system learns what the behavior of each and every equipment or component within the equipment is. And then once that's built off of historical data, you stream real-time data to us, and we continuously come back with predictions. And that prediction would be, say, is there a problem? Is there not? What's the confidence in the AI's decision? And then which of those data points is actually driving that decision? So it could be, it's the supply temp that's really out of whack. So yeah, it's meant to be not just, let's build an AI model, but let's put that into practice for real-time monitoring.
Well, very, very cool. So I'm guessing that there are probably a bunch of different ways you can sort of interface with a building system. I'm assuming one of them is like the building automation system, right? Just taking the data out of that.
Yep.
So it would be sort of okay. So that would be one way you could do it. Now, you mentioned a couple of times at the beginning of the interview, the industrial side of things. And I can see where industrial is probably way ahead of the commercial in terms of realizing the value in predictive maintenance, right? Because you've got a big assembly line and one part goes down, and I mean that could be millions and millions of dollars every day, right?
Yeah, so, exactly. And it's especially on the predictive maintenance side of when we first kind of attack this problem, it's critical equipment. What's critical equipment? So, and the industrial side, manufacturing, machine goes down, you lose however many dollars in the process. Our first building customer is actually a cannabis company where when their system goes down, they lose tens of thousands of dollars in growth. A lot of office buildings, it goes down and you're going to sweat a little bit more, or the opposite. But yeah, it's the critic. What equipment is critical, and that could be both from replacement cost, like let's say a chiller goes down, that's going to be far worse than a VAV. However, you also have to tie in the comfort and other areas where, as you start looking at it from the building side, it's equipment is equipment. From the AI perspective, data is data. But we've found success in the industrial side, and now really buildings are prime for this technology.
I think they really are. And there was a guy we interviewed years ago, a guy named Dr. Igor Mezic, and this was 6-7 years ago. And he was talking about, his vision was that he had this smart algorithm, he called it, which I think was essentially, an AI type thing. And what he was saying he could do, Jeff, was he was saying that he could basically, you just hook the sensors up to, give him the sensor input, and he would figure out the ideal program for each individual controller, the optimal settings for the equipment, and so on and so forth. I don't know how far he got with that because he was maybe way early in this whole thing. But is that sort of thing feasible based on what you're seeing?
Yeah, it's definitely feasible. I'd say on the optimization side, it's kind of the next thing for us. But the learning the system, the learning the specific system and how it operates is feasible today. Optimization is also feasible today, but not as everything that we try and do is make it as easy and out of the box as possible. So we're still working towards that on the optimization side. But in terms of feasibility, Absolutely. Like we're not too far away from, like I mentioned, the predictive maintenance, the end result is say an alert to the technician. We're not too far away from control. And I think part of that is going to be, which is similar to, the industry as a whole, it's going to be people getting comfortable with the fact that AI is controlling the system. But from a technology perspective, we're not far at all.
Got you. That makes sense. All right. So walk me through this. So I've got a brand new building, right? And I'm going, I heard this interview with Jeff, and I want to get way ahead of this curve with this thing. Now, I'm assuming that rather than having to wait for this data to come in, right? We got, in 2 years, we'll have this thing optimized because we will have learned your building. I'm assuming with the digital twin, you could just go, okay, we're going to run this thing through the building for the next 5 years on the digital twin, and this is how it should behave. Would that be one way you could get ahead of that curve? Or
yeah, so I think there's, again, it depends on the use case. So I'll talk about predictive maintenance and then more of like the energy side of things. So predictive maintenance, because we're learning the machine specifically, you need historical data, but you don't need a lot of historical data. You could turn a machine on, connect it to us, and in less than a month, or even a couple of weeks, say, learn what normal is for that machine and start monitoring it. On the energy side, let's say you turn a chiller on, day one, you're going to want to learn that chiller. But with that type of model, you could leverage learning from other chillers and other buildings. So you could leverage another digital twin. Let's say you bring a building on, you could use another building, another chiller to get a good gauge of, say, what the energy consumption of that chiller is going to be. And then as you collect data and this is the key point too for machine learning versus like rules-based optimization and things like that, is if it's a rule, someone has to go in and manually figure out what the thresholds are and then change it. With machine learning, it's going to relearn as it gathers more data. So you could start with, say, you put it on chiller B, it's learning off of what it got from chiller A, and then as chiller B starts to run, relearn off of that specific machine.
Right. And that's how we make the predictive maintenance, right? If we know that it runs this way, 98% of the time, and now all of a sudden we're getting different readings, we know something might not be quite right. Yep. Jeff, I'm wondering too, like a lot of these manufacturers, I'm sure Trane and Carrier and all these people that make chillers, for example, or air handling units, it seems like they would have a lot of that data to give you a starting point. In other words, the specifications say we should be able to do, the motors are going to run at this speed. And are you finding that they are willing to sort of hop in and provide that data to their customers to give to you?
Not yet, but I do think, they do have the specifications that we could run off of in terms of like openly sharing that. We haven't seen it yet, but that is a good benchmark to start with. Although it's funny, the number of people we talk to, it's like, okay, yeah, that's what our system is supposed to perform like, but they never do, that's even, but starting with that, it's, and like you said, Trane, Carrier, all of them, they all have the sensors, so they're all generating data. They have within their, the documentation, say, of what the range of a specific value should be. So I mentioned rules versus AI. You could start with rules and then learn from there. But I do wish there was a little more sharing within the industry of those specifications.
See, if I was Trane or Carrier or an equipment manufacturer, I'd probably be reaching out to you right now going, hey, Jeff, here's what we want to do. Let's put one of these systems, at corporate headquarters. We want to, as a value to our customers, we're going to monitor every single one of their chillers, right? Yeah. If we're selling chillers, so that we can alert them. They're not going to have their maintenance people do this, but through your software, we can alert them. Plus, we can also begin to find out just what our chillers are capable of.
Yeah, so
I think that might be a good use case.
And it's interesting. So you mentioned the industrial side that we worked in, and a lot of that was starting with OEM manufacturers. So not just monitoring their assembly lines, but monitoring their equipment once they sold it to the end customer. Because part of this and it's applicable for buildings as well with SIs, et cetera. AI could be another revenue stream for you. So on the industrial side, you're creating, say, a chiller. You can add value and revenue for the chiller manufacturer by selling this as a service. Or the SI or something, you could sell AI as a service to your end customer.
Yeah, no, it makes a lot of sense. And then, another great use case based on what you've said would be, especially with the building automation controls, you have a lot of what we call national account type people, like, a McDonald's that have multiple
Yeah.
locations. And it seems like not only could you, with your predictive software, just do the temperature or the equipment in the building, but it seems like you could probably, because it's just data points, right? You could probably predict how many hamburgers you're going to need to order, or how many hamburger buns you're going to need to order in the next week or whatever.
Yeah.
Right? It's just data.
Absolutely. Like we were talking to someone about in a smart environment in an airport, monitoring, trying to predict when to change the toilet paper in a bathroom. It's like, they make sensors that could track toilet paper, but those are really expensive. So you could use AI as a virtual sensor, if you will, to just, utilizing just occupancy and, people counting and, predict based on that. So yeah, to your point, it's like, okay, well, from a value perspective, we're starting with the mechanical side, with the machines themselves. But if you think about the industry from a smart building perspective, like they're starting with, parking lot optimization and, visualizing your data and just counting the number of people, et cetera. But the possibilities, I don't want to say are endless, but it's, there are a number of different things that can be predicted. And we've designed our system in a way to make it as generic enough to predict each and every one of those and then build it into an application. And so that for us is, we have a front end for dashboards and digital twins, but we also have the ability through our APIs to just tie the predictions back to another system, whether it be a building management system, et cetera, to allow that single pane of glass, or to allow someone to then build larger applications off of the insights that we're providing.
Yeah, so I guess that was kind of just where I was going with the question, and I'm gonna reframe it in a different way too. But just sort of to start out, it seems like you guys aren't limited. So in other words, if I come to you and I go, okay, I want to use this for my buildings, it's not like all of a sudden if I want to then count the hamburgers, you're going to go, okay, now you got to buy a completely different system. I guess what I'm getting at is, are you just adding additional modules on to it?
Yeah, so it's not even say a module. It's you can create different models based on what you want to predict. So as an example, we would demo and show the ability to predict failure on a machine, predict defects in the manufacturing process, and then I would throw in the ability to predict whether a major league pitcher was going to throw a fastball, because it's all data, right? It's just the applicability and the use case, it just depends on the end user. But to your point of it's hamburgers or a fastball, it's all data. And some of those models are going to be good and some of them aren't. But actually, that's one thing that's good about our system too, is it shows transparency. And what I mean by that is it'll show the end user, they build a model and it'll show them how accurate was it on the data that, you could have a model, it's horrendous, it's bad data in, bad data out. So you might say, oh, well, I don't want to put this into production. So, it's the ability to really build machine learning models, trust them, and then use them.
Okay. Kind of as we wrap up, Jeff. So I have a feeling a bunch of people are going to hear this and going to be interested, but walk us through the process. So, okay, I heard this interview. I want to deal with Jeff. So I'm sure there's a website you go to, but walk us through the process of just sort of how you go from connecting with Elipsa to being able to count my hamburgers.
Yes.
And predict the World Series.
So exactly. So you have the, maybe March Madness for right now, but
yes. Yeah. There you go.
So go to our website, Elipsa.ai. You could sign up for a free account, which allows you to bring data into our platform, build models, et cetera. That's an example. If you have, data that you can export, and then it'll give you documentation on how to connect the APIs. However, the easiest way is we've partnered with Tritium to be able to tie into Niagara, because for us, we're nothing without the data. Niagara is a huge source of data, a large customer base. However, they also just came out with their Niagara data service that is the absolute easiest way to tie into Elipsa. It's pre-built. All of your histories and your in Niagara are pushed to the cloud, interface with us. So the The easiest way is through Niagara. But without Niagara, any other system, you can interface directly through our APIs into any system that you have that has the ability to call an API or send data via MQTT.
Yeah, no, that's outstanding. Yeah, and most of the people listening to this, Jeff, you're absolutely right, are going to they're familiar with Niagara. They know Ed Merwin. They know the teams over there.
Yep.
And they know their Niagara distributor. So, yeah, I think that's probably the best way to do it. And then they still have access to you, but you get you and Ed, right?
Exactly. The combined forces, yeah.
Well, cool. All right. Well, listen, so you can go to Elipsa.ai. Yep. You can go to Elipsa.ai to sort of check it out. But then, hey, why do that when you can just reach out to your local Niagara dealer and get that same great service you're used to getting from those guys?
Exactly.
Jeff, man, I can't tell you, man, how much I appreciate you coming on and telling us about this.
Yeah, this was a lot of fun. Thank you, Eric. I appreciate it.
Okay, that's another week on Control Talk Now. Thank you so much for tuning in. Remember, be bold, stay in control, stay relevant, and man, gather some data and maybe do some AI with it. And as Hunter Thompson used to say, buy the ticket, take the ride.
Got me upside